So now you should have taken some time to already look at this case study and try and solve for the questions. If you haven't done that, please stop the video and go and do that. Because from here, what we're going to do is we're going to go through the answers and how we calculate the different amounts of energy and the time that you would want for the treatment. Okay, so you have your superstar tennis player who has had a tournament and now has developed pain in the lateral epicondyle of her strong hand. The laser that you have in the clinic is a single diode. The power of the laser is 100 milliwatts, and the wavelength is 150 nanometers, and the rest of it you can see. And you've gone to Walt and you've seen that for lateral epicondyle, you need to have, you've chosen to do 5 points over the area of her elbow, which is about 5 centimeters squared area. And you've chosen to do 4 joules per point. Okay. So now we want to see how much time is that going to take per point and how much time is the treatment going to take. And we'll start with those two. Okay, so if we look at time per point, okay, we'll come back here. And if we look at time per point, so how do we calculate time per point? So we're looking at the how much energy, how many joules are going to be delivered to that area, and how long do we have to keep the probe on. Okay, so we know that power is joules per second, right? So if we look at our 100 milliwatts, that comes out to 0.1 joules per second, right? That's what a watt is. Okay, so if you want, and now we want to deliver up here 4 joules. So we're going to go, so 4 joules, 0.1 joules is delivered per second. So I would put that as equals 1 second. Okay, we want 4 joules in X amount of seconds, right? Okay, so if we go back then X, if we solve for X equals 4 joules divided by 0.1. Okay, so X is our time, is going to be 40 seconds. Okay, does that make sense? So our time per our time per point is going to be 40 seconds. So if we've decided we're going to do 5 points, and 5 points for 40 seconds, so 5 points times 40 seconds per point is going to be 200 seconds, and that equals, so 60 seconds in a minute, so it's going to be 3 minutes and 20 seconds. Okay, so under 5 minutes for the treatment time. That sound all right? So if you guys are good with that, if you're not, you can go back and we'll go on to the next questions. So we had 40 seconds per point, 5 points for a total of 3 minutes and 20 seconds. So if we want to get the total amount of joules being delivered in that time, okay, there are 2 ways that we can look at that. We can take what we've just done, so we're going to do 200 seconds, okay, so 200 seconds times 0.1 joules per second, okay, it's going to be 20 joules, okay, so that makes sense to you. The other even easier way is we're just doing 4 joules times 5 points, right? And that equals 20 joules. All right, so we've got 20 joules being the total amount of energy being delivered over the treatment session. Okay, and then if we want to calculate energy density per point of application, so we know that we're doing 4 joules in, and the size of the diode is 0.5 centimeters squared. So 4 joules in 0.5 centimeters squared. All right, and that just means that per centimeter squared, then, if we want to get X, so per centimeter squared, we're getting 8, we have to double that, 8 joules in 1 centimeter squared. All right. So our energy density per point of application will be 8 joules. Okay, just another way to rate that then would be per centimeter squared. All right. So the last question that we had then, if we go up here, okay, energy density for the whole treatment area. Okay, I'll just grab that and we'll put it down in here. Let's make some room for this here. So we'll take this out. We'll take this out. Okay. That didn't work. Bear with me. Copy. And here. Okay, energy density for the whole treatment. So we said that we had 20 joules for the whole treatment. That's right, come on this. So 20 joules for the whole treatment. Okay, and that's over a total area here of 5 centimeters squared. So over 5 centimeters squared. Okay, so that gives us an energy density for the whole treatment of 4 joules per centimeter squared. Okay, and I hope that makes sense to you. So the energy density per point of application. So why that's important is that in each point of application, the energy is actually going to be more dense in that point. But then if we're looking at over the whole area, the energy density is going to be less. So we've only done points of application for about half of the whole of the area. And what that means, though, is that as the radiation energy is going into the tissue, it actually does spread, and it affects the tissue that is close to, in close proximity to where those photons are going to be landing. And so an energy density of 4 joules per centimeter squared is going to be effective over the whole area. Okay, so I hope that helped explain where some of the answers came from. If you weren't able to get exactly those values, we can go over them again when we get to the lab. And I hope you've enjoyed this learning online. I hope that you were able to take advantage of it, and I'm always happy to have feedback. All right.